Welcome back. This is lesson 2 on quantitative aspects of chemical change, and we are going to discuss the constants and Avogadro's law. So first of all, Avogadro's number. It gives the number of particles in 1 mole of any substance. So its symbol is Na, 6.022. Most people cut off the second 2 times 10 to the 23 particles. Now, a particle can be atoms or molecules, ions or ionic units. Next, I want to refresh your mind on standard temperature and pressure, STP. The standard temperature is 273 Kelvin or 0 degrees Celsius. And the standard pressure is 101.3 kilopascals or 101,300 pascals. Next, I want to revise molar volume. It is the volume of 1 mole of any gas at STP. You do get molar volumes at other conditions of temperature and pressure. So this one you can only use at STP. So from the ideal gas equation, we're going to want to calculate the molar volume of a gas. PV is nRT. We get the volume is the moles times the gas constant and the temperature divided by pressure. So if you have 1 mole of a gas and the value of R is 8.314, and the standard temperature is 273 Kelvin, and the pressure is 101.3 times 10 to the power 3 pascals. Then we get the volume of the gas is 0.0224 cubic meters, and that means 22.4 cubic decimeters. So every mole of gas at STP will have this volume. Avogadro's law says that at constant temperature and pressure, equal volumes of any gas will contain the same number of particles. So let's do an example. We're looking at helium and nitrogen and carbon dioxide. Let's say that the temperature is 25 degrees Celsius and the pressure is 1 atmosphere, 101.3 kilopascals. And let's say that we've got 1 cubic centimeter of each gas. Now in 1 cubic centimeter at pressure 1 and temperature 25 degrees Celsius, let's say we've got 1, 2, 3, 4, 5, 6 of these atoms, 7, 8 of these atoms in that 1 cubic centimeter volume. Then for the nitrogen, we will also have 8. 1, 2, 3, 4, 5, 6, 7, 8 molecules of hydrogen. And with carbon dioxide, we will have 8 molecules of carbon dioxide. 1, 2, 3, 4, 5, 6, 7, 8. So, equal volumes of any gases at the same temperature and pressure will have the same number of particles. Right, next we are going to look at the ratio between the mole and the volume of gases. The volume ratios of gases will be exactly the same as the mole ratio given by the balanced equation, because if you have the same volume and you have the same temperature and pressure, then there would be the same number of particles. So if you have double the one volume wise, the next one, the mole ratio will also be doubled. Maybe I'm confusing you. Let's look at an example. I've got 3 cubic decimeters of oxygen reacting with enough hydrogen to form water vapor. Calculate the volume of the water vapor. Let's look at the balanced equation. Oxygen is a gas plus hydrogen, a gas, forming water vapor, a gas. Now, to balance the equation, we need to double up on the water to balance the oxygens, and then we need to double up on the hydrogen to balance the hydrogens. So your mole ratio is 1 to 2 to 2. Now, if the mole ratio from oxygen to hydrogen doubles up, the volume ratio will do exactly the same because of Avogadro's law. So, at the same temperature and pressure, if you've got double the moles of hydrogen, it will have double the volume. So your volume ratio is the same as the mole ratio. So 1 decimeter cubed of oxygen will need 2 decimeter cubed of hydrogen, and it will form 2 decimeter cubed of water. I'm just explaining. Now we get to the question. They say you started off with 3 cubic decimeters of oxygen. So how much of the hydrogen is needed? Double the 3 and you get 6 cubic decimeters. How much of the water will be formed? It will be the same as the volume of hydrogen that was used, 6 cubic decimeters. So calculate the volume of water formed, and this is our answer. The second equation is petrol is a fuel containing a high percentage of octane. During the combustion of octane in the piston of an engine, carbon dioxide and water vapor is formed. Determine the total number of moles of gas formed by 1 mole of octane. So to do the calculation, we need the formula. You don't need to know the formula of octane this year. So it's C8H18 plus oxygen, O2, and it makes carbon dioxide and water vapor. Let's balance the equation. It seems like we need 8 carbons and we need 9 oxygens. Now, 18 hydrogens. So, oxygens here, I've got 16 plus 9, that's 25. I need to do my little mathematical trick here. 25 over 2 times 2 will be 25. So basically the balanced equation is 2 octanes needs 25 oxygens to make 16 carbon dioxides and 18 waters. So the mole ratio is 2 mole to 25 mole to 16 mole to 18 mole. So, determine the total number of moles of gas formed by 1 mole of octane is the question. So, 1 mole of octane will form 8 moles of carbon dioxide and 9 moles of water. So the total number of moles of gas formed by 1 mole octane is 17 mole. Then for B, the volume ratio between the gases. The volume ratio between the gases is 2 cubic decimeters of octane to 25 cubic decimeters of oxygen to 16 cubic decimeters of carbon dioxide to 18 cubic decimeters of water. Last example,